Welcome to this lesson on project delivery method, contracting strategy, and team alignment. In front-end planning, we often focus on the project need, scope definition, cost planning, schedule strategy, and risk identification. But there is another question that is just as important: how should the project be delivered? A project may have a strong business case, a reasonable budget, and a well-developed scope, but it can still struggle if the delivery method does not fit the project's risk profile. Problems often begin when an owner chooses a familiar contract form without asking whether it truly supports the project's complexity, schedule urgency, market conditions, or need for early construction input. In this lesson, we will look at delivery method, contracting strategy, early contractor involvement, governance, and team alignment as front-end planning decisions. These are not administrative details to be handled after design is complete. They are strategic decisions that shape how the project team works, how risk is managed, and how the project moves from planning into successful execution. Delivery method should be treated as a front-end planning decision because it affects almost every part of project execution. It determines when the designer and constructor become involved, how responsibilities are divided, how risk is allocated, and whether design and construction can overlap. It also influences the estimate, the schedule, the procurement plan, the risk register, and the overall project execution strategy. For a project with a stable scope, limited technical uncertainty, and little schedule pressure, a traditional sequential delivery method may be appropriate. In that situation, the owner may have enough time to complete the design before bidding the work. But if the project is complex, urgent, highly constrained, or dependent on specialized trade expertise, construction knowledge needs to enter the process much earlier. Waiting until the design is complete may cause the team to discover constructability problems, procurement risks, or schedule conflicts too late. That is why delivery method selection should normally begin during FEL2 and be refined during FEL3. The goal is not simply to choose a contract form, the goal is to align the delivery strategy with the actual risks and objectives of the project. This slide compares four major delivery methods: design bid build, CM at risk, design build, and integrated project delivery. Design bid build is the traditional sequential approach. The owner hires the designer first, completes the design, and then bids the project to contractors. This method can work well when the scope is stable, the design is well defined, and the schedule is not highly compressed. However, contractor involvement comes late, so it is less effective when the project needs early constructability input or fast tracking. CM at risk brings the construction manager into the process during planning or design. The CM can provide input on estimating, scheduling, constructability, bid packaging, market conditions, and procurement strategy. Later, the CM typically provides a guaranteed maximum price and assumes construction delivery responsibility. This method is useful when the owner wants to maintain a separate design contract but still needs early construction expertise. Design build places design and construction under one contract. This creates a single point of responsibility and can support schedule compression because design, procurement, and construction can overlap. However, the owner must clearly define performance requirements during front-end planning because the owner usually gives up some direct control over detailed design decisions. Integrated Project Delivery, or IPD, is the most collaborative model. It involves early participation by the owner, designer, builder, and sometimes key trade partners. It can support innovation, transparency, and shared problem solving, but it requires trust, strong governance, and experienced participants. The key point is this: there is no universally best delivery method. The best method is the one that fits the project's objectives, risks, schedule needs, and owner capability. Once the team understands the major delivery options, the next step is to match the delivery method and contract strategy to the project's risk profile. A basic rule is that risk should be assigned to the party best able to manage it. If risk is transferred to a party that cannot control it, the project does not become safer. It usually becomes more expensive, more adversarial, or more vulnerable to claims and change orders. For example, if the scope is incomplete but the owner demands a lump sum price, the contractor will likely protect itself by pricing uncertainty, adding exclusions, or submitting change orders later as the real scope becomes clearer. In that case, it may be better to delay fixed pricing, improve scope definition, or use a more flexible structure such as cost reimbursable, target cost, GMP, or phased contracting. Schedule pressure is another major factor. If the project requires early construction before the full design is complete, the delivery method must support fast tracking. CM at risk, design build, or IPD may allow earlier coordination among design, procurement, and construction, but fast tracking still requires discipline. Each work package should have clear design maturity requirements before it is released. Market capacity is also important. If qualified contractors or specialized trade partners are limited, late procurement may reduce competition and increase cost. In that case, early market sounding and a deliberate packaging strategy should be part of front-end planning. So the question is not simply which contract do we usually use? The better question is which delivery and contracting strategy fits the uncertainty we actually have. Early contractor involvement, or ECI, means using construction knowledge before key project decisions are frozen. This is important because many project risks are practical rather than purely technical. A design may look correct on paper, but it may still be difficult to build safely, efficiently, or within the required schedule. Contractors and specialty trade partners can identify these problems while the project is still flexible enough to respond. ECI can improve constructability by testing whether the proposed design can be built with available labor, equipment, access, and site conditions. It can strengthen schedule logic by checking trade flow, crane use, inspections, commissioning requirements, shutdown windows, and site constraints. It can also improve procurement planning by identifying long lead items, early release packages, and better bid packaging strategies. In constrained projects, contractors may recommend prefabrication, modularization, or alternative staging approaches to improve safety, quality, logistics, and schedule certainty. But ECI must be structured. It should not be casual advice that disappears after a meeting. The owner should define the scope of pre-construction services, required deliverables, review responsibilities, meeting cadence, and decision process. Contractor input should be documented and connected to the estimate, schedule, risk register, basis of design, and project execution plan. The value of ECI is highest when it happens early enough to influence decisions, not after those decisions have already been locked in. Delivery method and contract strategy cannot succeed without team alignment. Alignment does not simply mean that people are communicating politely or attending the same meetings. Alignment means that the right participants share a common understanding of the project's objectives, priorities, constraints, roles, and decision process. There are three related forms of alignment. First, business alignment asks whether the project supports the owner's mission, business case, and long-term value. This connects the project to the strategic reason it exists. Second, team alignment asks whether the project participants understand and support the same priorities. For example, in a renovation or transit project, the highest priority may not be lowest first cost. It may be maintaining safe operations, minimizing disruption, or protecting long-term performance. Third, governance alignment asks whether decision rights, approvals, escalation paths, and accountability are clear. The team should know who can approve scope changes, early procurement, contingency use, schedule recovery actions, and design changes before those decisions become urgent. Alignment also has to be maintained in three directions: vertically, horizontally, and longitudinally. Vertical alignment connects executives, sponsors, project managers, and technical staff. Horizontal alignment connects the owner, designer, contractor, consultants, operations, users, finance, and procurement. Longitudinal alignment protects the original business intent as the project moves from front-end planning into design, procurement, construction, commissioning, and operations. Tools such as RACI matrices, decision logs, alignment workshops, and alignment surveys can help the team identify conflicts before they become execution problems. Before Gate 2 or Gate 3 authorization, the owner should test whether the delivery method, contract strategy, market readiness, and governance structure are mature enough to support execution. This is more than an administrative checklist. It is a readiness test. The review should confirm that the selected delivery method matches the maturity of the scope, the urgency of the schedule, the complexity of the project, and the owner's internal capability. If the owner has limited staff to manage complex interfaces, the delivery strategy should not place excessive coordination burden on the owner. The review should also confirm that the contract type fits the uncertainty that remains. A fixed-price contract may be appropriate when the scope is well defined, but if major uncertainties remain, a more flexible contracting structure may be needed. Another important question is whether early contractor input has been obtained soon enough to influence design, procurement, schedule, safety, and site logistics. If ECI comes too late, it may only identify problems instead of helping the team prevent them. Finally, the owner should confirm that decision rights and stakeholder roles are documented and clear. The team should understand who is responsible, who is accountable, who must be consulted, and who must be informed for major project decisions. The goal of this gate review is to make sure the project is not only ready on paper, but ready in practice. Let's look at a practical example. A regional transit authority was planning an $850 million light rail extension in a major U.S. metropolitan area. The project included elevated guideways, 3 passenger stations, utility relocations, and a live tie-in to an operating transit hub. At first, the procurement team favored design bid build because the agency had used it before. They believed it would preserve design control and competitive pricing, but the project management and operations teams were concerned that DBB would bring the contractor in too late. The greatest risks were not routine construction activities. The real risks involved live rail interfaces, utility tie-ins, passenger safety, shutdown windows, and staging around an operating transit hub. To test alignment, the owner held a facilitated planning workshop with executive leadership, procurement, operations, design, safety, project controls, and construction advisory staff. The workshop revealed 2 major issues. First, the team did not share a common priority among cost, schedule, and operational continuity. Second, decision rights were unclear. The executive sponsor clarified that maintaining safe and continuous transit operations was the top constraint. With that decision made, the team shifted to a CM at-risk approach and brought in a construction manager during FEL2. The CM quickly provided practical field input. The team discovered that the preliminary excavation sequence would have required an unacceptable shutdown of a critical power feed. The CM proposed a top-down construction approach that allowed major structural work to proceed while station operations continued. The CM also helped develop phased utility relocation, early procurement for specialty track components, and a more realistic Level 3 schedule that included night work, access restrictions, safety reviews, and testing windows. As a result, the project entered execution with a stronger construction-sensitive baseline. Most importantly, the transit hub tie-in was completed without an unplanned shutdown of passenger service. This case shows the main lesson of the chapter: delivery method, contracting strategy, contractor involvement, governance, and team alignment should be decided during front-end planning, not after the project is already locked into a path.